Welcome to the lesson on polar coordinates, and let's start right away with the definition of polar coordinates. Okay, and this shouldn't be too different than what we've done before, but there is a slight difference. Okay, so a polar coordinate is an ordered pair r theta, where r is a directed distance. So that means if we go to the right, okay, then over here r is positive. And if we go to the left, then r is negative. Okay? And these are the only two options we have. Either go to the right or go to the left. There is no going up or down. Okay? And then theta is a directed angle. So if we rotate counterclockwise, then theta is positive. And if we rotate clockwise, okay, then theta is negative. So we could go to the right and then rotate counterclockwise. We could go to the right and rotate clockwise. We can go to the left and rotate counterclockwise, or we could go to the left and rotate clockwise. Okay, so there's four different possibilities here. Okay. And so maybe it helps a little bit more if we take a look at some actual examples rather than just talking about what these numbers mean. So it says here, graph the following polar coordinates and be as exact as we can. Okay, and if you remember in the rectangular world, so in rectangular coordinates, every time that we want to identify a point, we would say go some amount of distance this way and then go some amount of distance this way. Okay, but in the polar world, we have to treat things a little bit differently. So let me get my axis. In the polar world is actually a little bit different. It's a series of concentric circles. Okay. And rather than say go right some amount and go up some amount, we're given a radius. So we're given a radius of 4, 1, 2, 3, 4. And then we're supposed to rotate negative 60 degrees. So if we rotate negative, that's clockwise, about 60 degrees, that puts us here. That's Q. Okay. Or we go out 2, 1, 2, and we're rotating 5 pi over 6 radians, so that places us right about here. And that's R. Okay. Or we could also start with the negative radius, negative 2, so 1, 2, and then rotate 20 degrees, so that's counterclockwise, this way, so about here. So that's S. Okay. So you see here that the way for us to identify points on a plane in the polar world is for us to walk either right or walk left some distance, and then rotate some amount of degrees. Okay. And this is, more resemblant, more symbolic of how the Earth actually is. Every line of latitude that we learn about in geography is actually a circle. It's not a line, okay, because we actually live in a spherical object. Okay. So again, the main idea here is that polar coordinates is just another way of identifying points. Instead of going left, right some amount and then going up, down some amount, we just go some direction and then we rotate. And so now in these examples, we're asked to convert from polar coordinates to rectangular coordinates. In other words, we have these coordinates here. Remember, this is a radius and this is a theta, and we're asked to convert it to xy. Okay, so let's start with Q. Well, the x coordinate of Q, let me switch colors here. If we wanted to deal with this in the rectangular world, we have to go out some amount, that's x, and then we have to go down some amount, that's y. Okay. And so the thing that we have going for us here is that we know this radius. This is a radius of 4. Okay. So I want to redraw that picture so that it's a little bit easier for us to see. So we know that this radius here is 4, this is x, this is y, this is a right triangle, and this angle that we rotated from before, 1, 2, 3, 4, we rotated this way. This angle here is 60 degrees. Okay. So now we just use some basic trigonometry to help us solve this equation. So x is going to be 4 cosine of 60 degrees, and y is going to be 4 sine of 60 degrees. Okay. But keep in mind here, because this is down in the fourth quadrant, we know that y has to be a negative number. Okay. So 4 cosine of 60, cosine of 60 is just 1/2, so that's 2. Sine of 60 is root 3 over 2, so this is negative 2 root 3. Okay. And these are our rectangular coordinates for Q. Same thing if we are asked to solve and find the coordinates for R. Okay. Well, for R, we are going, let me use another different color here. So for R, we are going some amount of distance this way and then some amount this way. Okay. And so we have this little right triangle in there. So let me sketch this out. R, we have some x distance, some y distance here, and we have this radius stemming from the origin that has a radius of 2. Okay. Now this angle, we have to be a little bit careful in trying to figure this out. This angle here is actually pi over 6. Okay. So we remember that this is the xy plane, and we rotated a distance of 5 pi over 6. Okay. So we can solve for x and y just by using our basic knowledge of trig. X is going to be equal to 2 cosine of 5 pi over 6, and y is going to be equal to 2 sine of 5 pi over 6. Okay. And notice here, I could try and figure out what this angle really is, but I don't have to because I'm rotating this from standard form. So this comes out to be, remember, cosine of 5 pi over 6 is actually root 3, or negative root 3 over 2. So this becomes negative root 3. And then sine of 5 pi over 6 is 1/2, so this is 1. Okay, so these are my coordinates for R. Oops, I should move this up. And finally, for S, let's see. Well, for S, I'm running out of colors here, but I will give it a shot. We are going this distance here is 2, that's the radius. We have some x distance here and some y distance here. Okay? So for S, we have this right triangle. This is 2, this is x, this is y, and this is 20 degrees right here. And it turns out, again, we can solve this rather quickly. We know that x is going to be equal to 2 cosine of 20 degrees, and y is going to be equal to 2 sine of 20 degrees. Okay? But we know that x and y both have to be negative numbers, so that's, we just put negative in front of negative numbers and negative signs in front of that. And whatever this comes out to, that's going to be our final answer. And so there you have it. Just a quick conversion going back and forth between polar coordinates and rectangular coordinates. Okay, now I'm going to end this video here. In the next one, we'll look at how to convert from rectangular back into polar.